Jupiter's moons are some of the most fascinating objects in the solar system, and in the case of the closest of all of them, Io, it is no different. A world that taught us that the solar system is more active and alive than we could have possibly imagined. As just mentioned, Io is the closest of Jupiter's four largest moons. It was discovered by the Italian astronomer Galileo Galilei in January 1610, and the four Galilean moons were the first worlds discovered, besides the six previously known planets, the Moon and the Sun. It marked an expansion of our eyes into the universe at the time. Io is the closest of Jupiter's four largest moons. It orbits around 422,000 kilometers from Jupiter, which is just over the Earth-Moon distance. But Jupiter, of course, being a much more massive planet, means that Io goes around much more quickly around Jupiter. It goes around once every 42 hours, in fact. Much faster than our own moon, which goes around once every 29 days. As like most moons in our solar system, Io is tidally locked to Jupiter, so that means it always presents one face to the planet, and so that's basically a consequence of Io having the same rotation speed as it does its orbital speed. Io takes the same amount of time to rotate on its axis as it does to orbit around Jupiter once. And this proximity to Jupiter and the tidal locking to Jupiter has consequences, which we will go on to later. Io is about 3,600 kilometers across, which is only a few hundred kilometers larger than our own moon. Io's density is about 3.5 grams per centimeter cube, which is the densest large moon in all the solar system. And this is because it is made mostly of rock. Now this is unusual because most moons in the outer solar system are made of water ice and other sorts of ices. So why is Io the only one made out of rock? And in fact, this was known for a long time before we physically visited Io with a spacecraft. The ground-based telescopes on Earth for years had picked up hints that Io was completely devoid of water, unlike the other moons around it. Of course we didn't know what that meant at all. Its proximity to its parent planet has a lot of significant consequences, and one of them being that Io is completely bathed within Jupiter's radiation belts. It is, of course, the closest moon to Jupiter, so as I said in the Jupiter video, it is being cooked by Jupiter's radiation, and you can actually see this at the poles of the moon. Io is so deep into Jupiter's magnetosphere that it has a deep interaction with the magnetosphere. It actually causes something called a flux tube. Io moves through the magnetic field of Jupiter and creates a magnetic flux tube. A flux tube is essentially just a concentration of magnetic field lines. The reason we know this is because using Hubble, we've been able to see that Io leaves almost like a trail over Jupiter's aurorae. The magnetic field of Jupiter almost latches onto Io at both poles, and this means Io is an enormous electrical generator. It can generate millions of volts. So basically, Jupiter is supercharging Io, in effect. But here is the real interesting thing about Io. We didn't know anything about Io pretty much until the Voyager spacecraft got there, because Pioneer 10 and Pioneer 11, they didn't have the capability really to send much data back about it. It was in too high of a radiation environment. But Voyager was able to handle it. Voyager 1 more specifically flew past a very close flyby in March 1979, and it saw this colourful yellowy, whitey, reddish, brownish surface. This is because the surface is completely covered in sulfur. It looks like a giant spherical pizza, is what I like to call it, although that cheese is very nasty. But yeah, it's completely plastered in sulfur, and the Voyager team were very confused as well because they found not a single crater on the surface, which implies activity. Before Voyager, we thought the moons on the planets in the outer solar system are just dead, frozen worlds that won't have any activity on them. Scientists were already proved wrong by Io. And in fact, a few days after the flyby, a navigation image was taken to help Voyager 1 navigate itself around. And Io was in that image, just completely accidentally. And there was a mysterious object off of one side of the moon. And scientists had no idea what it was, because it wasn't another moon. Scientists eventually deduced that this mysterious object was an enormous volcanic plume. Io is the most volcanically active body in the solar system. It has an incredible heat output of around 100 trillion watts. And that, unbelievably, is the same as 23 tons of TNT per second. Io has these enormous volcanic eruptions all over it. It has so many lava lakes too, the largest of which is nearly 200 kilometers across. It's called Loki Patera, much bigger than anything that we've ever seen on Earth. Io is a fiery, explosive world in the outer solar system. Nobody expected that. So the question remains, what is causing these volcanic eruptions? How has Io got so much activity on it? Because Io is only slightly bigger than our moon, and the moon is dead. And even objects that are bigger than Io, like Mars, are dead worlds. The only reason Earth has volcanic activity is because it still has its heat of formation left over. Because it's a large rocky body, it's kept in that heat for billions and billions of years. Io is much smaller, so it would have lost its heat of formation long ago. So something else is at play here. And the answer lies with its proximity to its gigantic parent planet Jupiter. Jupiter, of course, being the biggest and most massive planet in the solar system by far, has an enormous gravitational effect on Io. It pulls and tugs on the moon as it orbits, and Io's orbit is not perfectly circular. It's ever so slightly elliptical, and that is also important. So as Io orbits Jupiter, it's ever so slightly closer and then far away from Jupiter, closer and then far away. So that means that the gravitational pull on Io is constantly changing all the time, and that really puts an immense amount of stress and strain on Io itself. The interior heats up enormously by just simple friction. Now, if Io were Jupiter's only moon, then the elliptical orbit would gradually become circular. But Io is not Jupiter's only moon. There are 3 other large moons around Jupiter, and 2 of them Io has something called an orbital resonance with, Europa and Ganymede. An orbital resonance is essentially an alignment in multiple objects' orbits on regular intervals. So for every 4 orbits that Io does around Jupiter, Europa goes around twice, and Ganymede goes around once. And this regular meeting of these 3 bodies means that they impart more gravitational strain on Io, which keeps its orbit elliptical. And that keeps the volcanoes going, because if Io's orbit became completely circular, there'd be no gravitational change, and therefore the volcanoes would die down. So this gravitational process of stretching and squashing the moon with gravity is called tidal heating. If you think about the tides on Earth, they're caused by the moon, and the gravity of the moon acts to pull water slightly up, which changes, of course, the tides. The Earth also has gravitational effect on the moon. The effect on the moon is much more powerful. If the moon had liquid on it, the Earth would cause even more extreme tides on the moon. That doesn't happen, of course, because the moon has no liquid on it. But in the case of Io, Jupiter, of course, is much more massive than Earth, and so Io is subject to its immense tidal gravity, and so Io actually experiences rock tides. Jupiter straight up lifts the rock something like 100 meters up and down as Io goes around in its orbit. Can you imagine that? all the way across the moon. 100 meters is huge. Imagine the stress inside the moon and all the heat that's generated. Then you can see it. There's no wonder Io is so explosively volcanically active. One of the most utterly fascinating places in the solar system. Really does definitely deserve more exploration. The icy moons of Jupiter now are getting a lot of attention, and rightly so, because they are potential habitats for life. Io is vastly different from the other 3 moons of Jupiter. It's a fiery furnace of volcanic eruptions, and it does deserve more exploration. It deserves its own mission. The Io Observer mission was a mission proposed to NASA in the latest Discovery mission contest. It sadly lost out, although it was a finalist. It is still something that NASA could consider for the next Discovery mission, which would be super cool. I would love to see more science about Io. Generally one of the most fascinating objects in the solar system, for just completely different reasons than all the other moons of Jupiter. Thank you everyone for watching this video. I hope you all enjoyed it. I certainly always enjoy making these videos. Please feel free to like the video if you enjoyed, and subscribe for more space content if you want. It's free. Thank you all for watching this, and I'll see you all in the next video. Goodbye!